I am very happy to be here on stage to talk not about supply chain security, but insecurities and attacks. Because maybe you've noticed the Go team has been telling us, oh, they've been doing a lot of work to try and prevent these, very dangerous supply chain attacks. But have you seen a supply chain attack yet in Go? Well, today you will. So what is the problem we're trying to solve? Well, if you were there this morning, maybe you've seen Jess McClintock talk about supply chain threats and how to, tackle it with static analysis. So I don't need to introduce supply chain attacks, do I? Well, maybe I might want to talk a little bit about what supply chain attacks are like in the Go ecosystem. So if we look at how dependencies work, you are usually pulling dependencies, from GitHub or from random people's proxies because of the way the Go proxy works and everything. And you don't really know what kind of code you're pulling unless you're looking at the code. But you can't really know for sure the code you're looking at on GitHub is actually the code you're pulling from the tagged version that is on the Go proxy. Sure, we have a checksum database on which can check in the checksum database the code we've pulled matches the checksum that has been, pulled in our code, in our binary, but still there isn't any easy tooling to do so. And actually, typo squatting attacks in Go do happen. So for example, there is a cirruspen and cirrupsen logrs packages, and it's very easy to do typos when you're typing in your editor. And so these things are actually a problem in Go. But again, you can refer to this morning's talk to learn more about supply chain attacks. So my example today is about the crypto RSA package, which is a standard library package that allows you to do encryption, decryption, signature, and verification of signatures using the RSA algorithms. And the funny thing about the RSA package is that its verify function is returning an error. And so here it says a valid signature is indicated by returning a nil error. So that is, idiomatic Go. So if you want to verify a signature, you would write something like this. If there is an error that is not nil, then there is a problem and we need to handle it. But is there maybe a problem here around dependencies on supply chain? Well, the return error verification done by the RSA package is actually using a global variable at the RSA package level. And anybody can change variables that they are importing. If you're exporting a global variable, then people pulling your package can change that variable. It's the point of having a variable instead of a constant, right? And so somebody could be doing something like this. And this is a supply chain attack against the crypto RSA package, because then you can poison RSA verification and make it pass all the time. Suddenly, your signatures, even if they're invalid, will still return a nil error value. And it's, unless you're reading all your dependencies code, right, it might be difficult to spot such a small change. And if you want to try it for yourself, you can actually do so. So I've created a never import with RSA package that you can just import in your package like that, and you'll see suddenly your signatures are passing even though they're invalid. And this is a link to the playground to test it. So can we do something about it? Is there a workaround? Well, how about using error is, to match the RSA error verification. So you could be saying, oh, what if error is an RSA error verification? Wouldn't that work then because of the type system we have and we know it's the error verification type? Well, not really. So that will actually detect the problem when you have an invalid signature not passing. But I lied, because actually it will make every signature stop passing because you're doing error is nil in case of a poisoned RSA package. And so suddenly you get plenty of false negatives instead of getting false positive. which is probably better for cryptographic code. But anyway, so we can't really, tackle or find a workaround for the RSA package API problem. But what can we do then? So another way of doing it would be to use the same technique as in crypto ECDSA, which is doing also signature verification, but this time is returning a Boolean. And if it's false, the signature is incorrect. If it's true, then the signature is correct. You might think, oh, we got the solution, right? Because exported function cannot be modified by other packages. So you can modify exported variables, but you can't modify exported functions. And so nobody can change the way the verify code works now using a supply chain attack. Or maybe actually they could be doing something nefarious, because if you're not trusting your code you're pulling from strangers, then you can't know they're not doing an exec of a malicious payload, or they're not using unsafe code. And maybe you know of Ken Thompson, who's one of the co-designer of the Go language and who's working currently at Google, who said, you can't trust code that you did not totally create yourself, especially code from companies that employ people like me. And so, if you ask me, we as a community have a supply chain problem with Go, because we have so many dependencies we can't trust. And hopefully, we'll be able to get there, but with better tooling and, by putting a lot of work into it. But for now, it's not there yet, I'm afraid. Thank you very much.